Fine. I started recording, so very good. And the next step will be sharing my screen with you. So, grounded vessel, this is the topic of our interest. And maybe it would be good idea if we discuss from the very beginning what is going on. So, to sum up previous lecture, what are we talking about now? Maybe somebody of you, some a student who is the bravest one, will summarize where we are, what is the problem we are discussing, and at what stage are we now. Who is bravest and want to summarize last meeting, last lecture? I turn myself to the group to observe who wants to speak. Nobody. What is the problem? Can you see the slide? Please confirm.
Yes, we can.
Yes, so you can read what event is the subject of our today's and previous meeting analysis. So what is the problem?
We are talking about a grounding vessel, and we try to calculate the variables, which are the point of action of the reaction and the amount of the reaction force.
Okay, so the problem is that our vessel is grounded, so in the stillness, does not move, and the displacement, the weight of the ship is supported by two forces. The first force is displacement, and the second force is reaction between the ground and the hull. Batuhan, am I right? Is it your understanding?
Exactly,
Yeah.
sir.
Yeah,
We are
the weight of the ship. If I have, if I want to put equation describing the sentence, it would be like that. Mg, this is the weight of our ship. It is the weight is supported by the displacement. I will put here letter G as grounded, displacement of the grounded vessel, plus a force, additional force, which is reaction between the hull and the ground. Maybe I will use gray color to show displacement of the grounded vessel. This is that one. Okay, displacement of the grounded vessel. And total weight of the ship, total displacement, probably I have to add this piece of the hull. Yeah. Okay, so blue plus gray, this is displacement of freely floating vessel. Gray, it is displacement of grounded vessel. Yeah, so we have two forces: displacement of grounded vessel, which is less than displacement of freely floating vessel, and additional reaction between the ground and the hull. And our purpose, as Batuhan said, is to calculate the value of the force and two variables that describe position of the point of action. Yeah, the point of action. XP, how far is point of action from aft perpendicular, and YP, how far is the point of action from the central line. The last number, 0, this is the result of our assumption. We did assume that the point of action is placed on the baseline. So the third ordinate is equal to 0. Okay. And then last time we started to think about what numbers what could be the source of data for calculations. Yeah, if you want to calculate the force, what shall be the data of for our calculations? And this slide shows the result of our discussion. The first source, the first package of information is the loading condition before grounding. Before grounding, it means freely floating vessel. Yeah, the loading condition. This is data for our calculations. And we concluded that if we know the loading condition, we know the loading condition in terms of four numbers: displacement of freely floating vessel and position of the center of gravity, three ordinates. If we know the loading condition, we are able to calculate foredraft, aft draft, and additionally we are able to calculate port side draft and starboard side draft. Yeah. So these four numbers, foredraft, aft draft, port side and starboard side, four drafts are known to us because we know the loading condition, so we can calculate this. And if I remember correctly, Wednesday, I suggested, actually I did encourage you, if there are students in our group who are not able to calculate fore and aft draft now, today, they have the homework to do, let's say on Saturday or on Sunday, just to refresh, just to recall the method of calculation of fore and aft draft, and of course angle of heel, using tangent, for example, function, and at the same time port side and starboard side drafts. So this is my hint to you. In my opinion, it is the best time now to refresh this knowledge if you don't know or if you don't understand the method of calculation of fore and aft draft. Okay, and then we started to consider the second package of data. It means drafts fore, aft, port side and starboard side after grounding. The first package before grounding and the second package after grounding. And who will remind us how to determine drafts after grounding? Who can answer such question? What could be the method of determining the drafts after grounding? I open the floor for the discussion. The first package before grounding, it means calculations, and after grounding, what could be the method of determination, the numbers? Who would like to take floor and tell us?
We need to calculate the displacement after grounding, so we need to check the draft marks forward and aftward, so we will have a mean draft that we can calculate.
So, if I understand you correctly, Batuhan, your idea is to measure four numbers, to measure, the measurement is here keyword, to measure drafts from draft marks. Am I right?
Yes.
Okay, very good. So these numbers will be measured. It is very easy to say that you have to measure drafts after grounding, but I hope you can imagine that it is so-called very good question, how to do it in practice. How to do it in practice when the ship is grounded, there are waves, the ocean surface, sea surface is not calm, everything is moving around, and Shosda says just measure drafts after grounding. In my opinion, I will put here a question mark. In my opinion, this is the most maybe a little bit dangerous, yes, the most dangerous, and secondly, the most difficult part of the procedure. How to measure drafts after grounding. Maybe I have a slide for what could be the method. Yes, I have. Okay, so let us turn to this slide. How the draft may be determined. Draft, it means we need four numbers. We need four numbers. 4 after grounding, draft aft after grounding, draft port side after grounding, and draft starboard side after grounding. So I mentioned here about 1, 2, 3, 1, 2, 3 methods. The first method is the easiest one. Just if the ship is equipped with remote system of determination of the drafts, this system can be used. But it seems to me it is not so frequent. I can name ships that you can read drafts of your ship staying in the wheelhouse. Just in the wheelhouse you have possibility to watch the draft of your ship, but it is rather rare. This is rather rare. The next method I mentioned here is launching a lifeboat and just to go around the ship, to go very close to the draft mark, very close to the side, and read from the draft mark what is the draft of your ship in particular marking. And the last method I mentioned here is using a rope with a weight at the end. My imagination of such a method is that you can check, maybe you can choose a place on deck and measure using rope and a weight at the end the distance between the deck and the water line. To do the same, let's say in another place, to check what is the distance between deck and the water surface, and do the same the third time, for example, close to the aft, to measure using a rope and a weight what is the distance between the deck and the water surface. And as a final, you have 3 points, you have 3 distances, it means you have 3 points, and you know that your actual water line goes through such 3 points. I am not experienced in such determination of drawing, but it seems to me that this is a method that can be used frequently after grounding. Not to measure drafts directly, on draft marks. It is almost impossible in ship operation. Rather, to measure drafts in another way, just determine the distance between points on the deck and the water surface and you have actual water line like this. Okay, if you need really draft on draft marks, you can use general arrangement of your ship. If you have water line, and you may draw curve, and using this curve determine drafts on aft, midship and fore. Okay, so in my opinion this is the most frequent method and maybe safe. Maybe there are other methods. Maybe there are other methods you can do. You can measure draft but I cannot at the moment name such methods. Okay. Maybe you are surprised that my water line is not a straight line. My water line, the green one here, is not a straight line.
Sagging or hog, the vessel will
Yes.
bend.
Very good. I wanted to stress a problem. I wanted to highlight a problem. Maybe our ship is hogged or sagged. So the ship might be maybe bent to some extent, yeah. So hogging or sagging. On my in my picture, Batuhan, you talked about hogging and sagging. Is my ship hogged or sagged? How do you think, Batuhan? Or anybody else, of course. Is my ship hogged on or sagged at the moment? Fore and aft drafts. Fore and aft drafts are bigger than midship draft. The ship is
Sagged.
hogged. No, hogged.
Is it?
Yes, it is.
Sorry, the green line is our vessel's shape or the water line's shape?
Water line. Green line here is water line.
So less part of the vessel underwater and the middle, so it's
Yes.
hogged.
Yes, it is hogged.
Because it's
It is
of
hogged.
water still. It's not inside of the water.
Okay, so we agree. Am I right? The ship
Yes.
is hogged. Yeah, the ship is hogged. Okay, and why I mentioned about this, why I highlighted this, because a very interesting question emanates from this phenomenon. The ship may be hogged, or in another way, the ship may be sucked. So the question is, what is mean draft? What is mean draft? If we measured for midship and aft drafts, and if we assume that the ship is bent along a parabola, this is important here. The ship is bent along a parabola. So my green line on upper picture, it is parabola. So the formula for the parabola is like that. If you know what is for midship and aft draft, you can determine from this coefficients A, B, and C. It is possible because, for example, TF after grounding, it is A times, let's say it is LPP here. So it is on the 4 perpendicular. So it will be LPP to the second order plus B LPP plus C. Okay. T midship after grounding, it is A LPP divided by 2 to the second order plus B LPP 2 and plus C, and T aft, it is A 0 to the second order, B 0 plus C. You have three equations. If you have three equations, you can calculate what is A, what is B, what is C. So the equation for green water line can be found. Green water line, of course, in the reference system related to the ship, yeah, in a reference system related to a ship. If you have a parabola, you can then calculate the amount of the volume of displacement, assuming that we have a straight line connecting aft and fore perpendicular. Okay, and volume which is of our concern is volume related here between straight water line and this which is assumed parabola. If you consider the problem in this way, so starting point is assumption that this is parabola. If we consider the problem in this way, the final formula we can develop, we can justify to some extent, is that you want to calculate mean draft that corresponds to the green water line. You should take 1 fore, 1 aft draft, 6 midship drafts, and sum of such drafts you have to divide by 8. This is so-called draft mean of means. Very often in ship operation, the name of such mean draft is mean of means. Mean of means. The draft that represents mean draft of our ship after assumption that a real water line in reference system related to the ship, it is important, is parabola. So mean draft, I will take maybe red color like this. The mean draft will be somewhere here. Somewhere here there will be mean draft, TM, so-called mean of means. So this is the reason why I put such a formula to calculate mean draft after grounding. Yeah, mean draft after grounding. The background of this formula is that the ship is bent somehow. The ship is bent, and this phenomenon is taken into account, assuming that the bending line is parabola and mean draft of your ship. I hope that formulas for trim after grounding and tangent of the angle of heel after grounding are obvious for everybody. I hope so. Trim, this is the difference between fore and aft draft. Yeah, so it should be obvious. And tangent of the angle of heel after grounding, of course, this is starboard draft minus port side draft divided by breadth of our ship. If I have to put a drawing that defines the last formula, I think the drawing could be like that. Angle of heel, maybe a bigger one. Okay. Angle of heel, let's say like that. Central line, and we need to calculate the angle of heel. This is phi g, our angle of heel. So what could be the formula? Very simple. Starboard side draft measured after grounding. So it will be T starboard after grounding. Here we have port side. Once again. Port side draft after grounding. So tangent of the angle of heel is just difference between starboard and port side divided by breadth of our ship. So I hope the formulas that can be used for calculation of the mean draft, trim, and angle of heel are obvious now for everybody.
Sir, excuse me, I have a question.
please.
Can you show the slide 11? So the next one.
This one. Okay.
Yes, and it's like, what is TMG here? TMG. It's the second formula.
Here.
Yes, TMG.
TMG. Okay. This is draft at the midship after grounding. So if I show here the midship like that, and the distance is LPP over 2. So this is what has been measured at the midship. TMG, draft of the midship after grounding.
Okay, and one formula below it's like aft. Yes.
Yes, aft.
Aft.
Yes, so I did assume here this is aft perpendicular. So after the ordinate of the aft perpendicular is just 0. Yeah. If we have aft perpendicular here and we measure draft as the aft perpendicular, it is just TA. Sorry, I will put here G after grounding. Yeah. So it will be that number T aft after grounding. Yeah, draft aft after grounding. So the ordinate, longitudinal ordinate of this point is just 0. This is the reason why I put here 0. So for perpendicular midship after grounding in half of the length of the ship, and aft draft after grounding, it means at the beginning of the reference system. This is the reason why I put here such numbers. LPP 4, LPP over 2, midship, 0, aft. And if you measured drafts in these points for perpendicular, midship and aft, you can obtain from such a trio, three equations, you can find out what will be A, what will be B, what will be C for Rio parabola. And then you calculate volume, which is between the parabola and the straight line, and you take into account this missing volume, and the final formula for the mean draft that corresponds to real volume of displacement is like that. And the most important here is this coefficient 6 over 8. Yes, 6 over 8.
Sure, and this TFTA is of course after grounding, yeah, also.
Yeah, this is general formula. If we use this formula for freely floating vessel, this is TF. After grounding, of course, it will be G. And it seems to me I did put G here. Yeah, here. Can you see?
Yes.
After grounding, after grounding, and midship after grounding. Midship here means in the half of the length between perpendiculars. So the final stage is that we have two sets of data for our calculations. The first step, this is information about the drafts before grounding, so freely floating ship. Then you can calculate mean draft, you can calculate trim, and you calculate possible angle of heel before grounding. Usually phi is almost 0. Yeah, the angle of heel of the freely floating vessel in the voyage should be close to 0. But okay, I put here letter phi it might be non-zero value. But to sum up the set number 1, mean draft, trim and angle of hill before grounding. Then after grounding we measure, it is very important, we measure somehow using any method like a rope. We measure drafts. We calculate mean draft after grounding, trim after grounding, and angle of hill after grounding. And we have 2 sets of data for further calculations. And the third step here should be obvious for everybody. Number 3. What did I calculate here? Who will answer the question? But Batuhan, please sit silent for a moment because
Hello, sir.
yeah. So God's power, yeah.
Yeah, what you calculated last is the difference between drafts before grounding and draft after grounding. That's what you basically calculate here.
Yeah, this is stage number 3. Very good. Stage number 3, in our case, this is calculation of the change. Before grounding, midship draft was TM. After grounding, we measured somehow it is TMG. So TMG minus TM, final, after grounding, minus initial, before grounding, it states the change alteration of mean draft. The same for trim, delta T, it is change of trim, final minus initial, and delta phi, this is change of the angle of hill. Phi G minus phi. Phi G, it is final after grounding, and phi, this is initial of freely floating vessel. If we assume, and usually they do, that initial angle of hill is equal to 0, it means that change of the angle of hill is equal to angle of hill after grounding. So we can take it that tangent of the change of the angle of hill, this is just tangent of the angle of hill which has been measured after grounding. But this is of course assumption. If we assume that during the voyage, the ship was in upright position, in transverse direction, yes, so there was no hill. Hill was equal to 0 or almost 0. We can take it that change of the angle of hill, this is the same angle of hill that has been measured after grounding. So tangent of the change of the angle of hill, it is tangent of the angle of hill after grounding. Okay. Now the general question, does everybody understand the meaning of 3 steps at this slide, on this slide? Maybe the students that want to ask a question, maybe everything is obvious. The floor is open. If you have a question, if you want me to add something to this, please do it. Please ask a question. I will answer. 3 steps before calculation, data, it is loading condition before grounding. The second step, it is measurement, drafts measure after ground, the drafts measured after grounding, measurement, it is very important. This is source of data. You have to measure drafts somehow using a method. And the last step here, step number 3, it is calculation. It is calculation of the change of mean draft, change of trim, and change of hill. Yeah. So how many degrees of freedom we consider now? Who will answer the question? How many degrees of freedom?
Just 2.
How many?
2, trim and hill. That's only what you consider.
Yeah, 3 degrees.
Yeah, 3
degrees of freedom. We state that due to the grounding, as a result of our grounding, the ship changed mean draft. It is the first degree of freedom, vertical. The ship changed trim, so this is rotation. And the ship changed angle of heel. It is also rotation, but in transverse section. Changing of trim, this is rotation longitudinally, and changing angle of heel, this is rotation transversely. 3 degrees of freedom. Number I put here 3 is important. Why? Because we stated at the very beginning that we are interested in 3 variables. We want to calculate the force. We want to calculate 2 ordinates of the point of action, longitudinal and transverse. Vertical is assumed to be 0. So 3 degrees of freedom. I am back to those slides. 3 degrees of freedom, change of mean draft, change of trim, and change of angle of heel. Then we can put 3 formulas, 3 equations. If we can put 3 equations, it will be possible to calculate 3 variables. Number 3 here is key word. Yes, is very important. 3 variables. Okay. And now the next assumption, hopefully last one. We will take it that force acting on the hull of our ship, the force acting vertically upwards, it is discharge weight. So instead of force that acts between ground and the vessel, we will take it that a weight, maybe I shouldn't put weight here, a weight which is placed at the coordinates of the point of action, so somewhere here, the weight has been discharged. The weight, N, has been discharged. So I will delete for a moment the force here, and I will assume that weight has been discharged from point A, from point of action, and the same in transverse direction. There is no force here, which is external for a ship. There is a weight. The center of gravity of this weight is placed in point of action, and the weight has been discharged. And the question we will put will be, what shall be weight and what shall be the center of gravity of this weight to observe the same change of mean draft, trim, and heel as it has been measured after grounding. Once again, it is important to catch the point. Actually, a force acts between the ground and the hull in longitudinal and transverse direction. I deleted the force and replaced this force with a weight that belongs to the ship. So now it is not external, it is internal, a weight. And this weight will be discharged, this artificial, imaginary weight will be discharged from the ship. And the question will be, what shall be the weight and what shall be the point, the center of gravity of this weight, what shall be weight and position of the center of gravity of this weight, to observe the same change of mean draft, trim, and heel as it has been measured after grounding. So this is the model, this is the idea. We will be looking not for force, we will be looking for weight. The weight, it will be a model that replaces real force. And I open the floor for those students who didn't catch the idea, didn't catch the point. Maybe you want to ask a question. I open the floor. Silence.
Hello, sir.
Yes, please.
I caught the point, but the diagram from the first from the sixth slide, there's something I wanted to show what it is because you wrote some alphabets there. I already know what N is. N is the force that's acting on the point. What is A? B, okay, BL is the baseline. I get that. What is A, CL, and I think, okay, what's A at that point? A and C.
I switched off the camera so you don't see I'm smiling now. Okay, A, this is point of action. This is point. A here is point of action. Probably I wrote here letter A as the first letter of the word action. So what is real situation? The real situation is that there is area of contact between the ground and the hull. This is actually area. But last time, on Wednesday, I proposed to replace area with point, and at the same time to replace pressure that acts between the hull and the ground, to replace this pressure with a force. Yeah. So actual situation is that there is area of contact. This area is replaced by a point. Name of this point is A, point of action of the force, and of course the force is somewhere here. Yeah. So N, it is force that replaces pressure above the area, and A, this is point of action of this force. And I did assume at the last stage that the point of action, this is the center of gravity of artificial weight that will be discharged from the ship. BL, it is baseline, and CL, this is center line. It seems to me you also asked for CL and B or BL. CL is the center line, so reference system of our ship in our drawing, and BL, this is also reference line, baseline. Yeah, so here we have axis Z, and here we have axis Y. Yeah, Y lies on baseline. This is just reference system. And God's power, I turn to you. Did I answer your question?
Yes, sir, you did. Because I was trying to understand the picture, but now I do. Thank you.
Thank you. Okay, but at the same time, I thank you, God's power, because usually you ask the questions, and it seems to me there are other students who maybe wanted to ask the same question, but you are bravest. You are bravest, so you ask the question. But probably I did answer also to other students who didn't follow. What does it mean? A, this is point of action of the force, action force, and at the same time, this is the center of gravity of artificial weight that represents the force, and this weight will be discharged from the ship. And the question mark will be what should be such weight, and what should be the center of gravity, described by 3 numbers, in order to observe the same change of the mean draft, the same change of trim, and the same change of the angle of heel, that it was measured, it has been measured after grounding. So after grounding, you observe new drafts. In general, it means new mean draft, new trim and new angle of heel. And you ask a question, what shall we artificial weight that has to be discharged from the ship to create the same changes in terms of mean draft, trim and angle of heel. Before I show you the next slide, I turn to group and ask the question, does everybody understand the idea? It is important before we proceed further to make sure everybody understands. Silence. So, as usual, I take the silence as everybody did catch the point, everybody understands the idea. If so, the next step should be very easy, not difficult. How can we calculate change of mean draft? After discharging weight, we can use TPC. Yeah, so change of the mean draft, it is the weight that has been loaded or discharged from the ship and divided by TPC divided by 100. Change of the trim, this is the force, the weight that has been discharged, multiplied by the distance between point of action and pivot point, center of rotation. This is moment acting on our ship and moment in longitudinal section. If we divide the moment by moment to change trim, we will obtain change of trim. I am not sure, shall I show the second formula? Okay, maybe I will do it. Here is the weight we want to discharge, position of the center of gravity. Here is the center of flotation, yeah, and the moment that has been created by discharging the weight from XP will be the weight. Weight, it means the force we are looking for, multiplied by the distance between point of action and position of the center of flotation. I am not sure what was the abbreviation of this, so I am back to the formula. XF, okay, XF. So I will come back here and put XF. I hope that everybody remembers that in our hydrostatic table, longitudinal position of the center of flotation was abbreviated LCF, longitudinal center of flotation, yeah? Okay. But I wanted to use the same abbreviation as here on the slide, yeah? This is the same as LCF, longitudinal center of flotation. And moment to change trim, of course, you should understand. And the last one, tangent of the change of the angle of heel. This is moment that acts on the ship in transverse direction, divided by the displacement after grounding, of course, and divided by initial metacentric height, of course, after grounding. And it seems to me the drawing that shows the third formula may be like that. Here is center of flotation, here is YP, point of action of our force, line of action, and the force is N. So what moment acts in transverse direction? The force multiplied by the distance between point of action and center of flotation. I put here YF as equal to 0 because I did assume that our ship, the shape of our hull, is symmetrical. If symmetrical, so the center of flotation, the center of the water line in transverse section is placed on central line, so the distance between F and central line is equal to 0. So to simplify, we can put such formula for the healing moment created by discharged weight or by our force we are looking for, and this is explanation of the last formula for calculation of the angle tangent anglophile. Okay, fine. So now I take gray color and show what we are looking for. We are looking for N, XP, and YP. N, XP, YP. I hope you remember TPC, tons per centimeter, LCF, longitudinal center of flotation, MCT, moment to change trim, KM, vertical position of the metacentric point, may be found in, and I I want you to continue to finish the sentence. Where can you find hydrostatics? Oh, I did answer the question. Sorry, sorry for doing this. TPC, yeah, LCF, or at the same time XF, MCT, KM may be found in hydrostatic table, yeah, hydrostatic particulars. So the numbers are known here. Yeah? Some numbers are known. Fine. So the last slide of this group, calculation of variables we are looking for: the force and point of action. Delta Tm measured, delta T measured, delta phi measured. What else? TPCG, it is ton per centimeter for mean draft at after grounding. MCT the same, XF after grounding, and GM you have to calculate additional GM after grounding. Here we have hidden KM after grounding. Yeah? Here shall be used. Okay, so one by one, the first degree of freedom, the second degree of freedom, the third degree of freedom, you can calculate what we wanted to do. I think there is one issue remaining: how GM after grounding shall be calculated. Yeah, I am back to the final formula. We have to use GM after grounding here. I think it is obvious for everybody how to do it, but to be sure, I will open the discussion and ask a group, ask everybody how GM after grounding, how initial metacentric height after grounding may be calculated. So I open the floor, but Batuhan, please sit silent. You answered at least twice, maybe 3 times today. Maybe another student. I switched my tablet to Teams and I observed the group in terms of abbreviations, of course. I can see who is Capitan Sparrow. Okay. God's power, I think you want to take.
Well, I want to try. I
Mhm.
don't. Well, I think first of all, I think we'd need the displacement after grounding to be able to proceed. So
Yes.
if we have the displacement after grounding, we can calculate the center of gravity with it after grounding.
Mhm.
And also I think we also need to calculate free surface correction.
Mhm.
Then
I think we will assume that free surface correction is constant. You are right. The free surface correction will change to somehow because displacement changed. But let us skip the problem of free surface correction for the moment. So you said the first step could be determination of the displacement after grounding, then calculation of the vertical coordinate of the center of gravity after grounding, and the last step you didn't say, GM after
the
grounding.
the vertical metacenter point after grounding also we need it. Yes, so we subtract the center of gravity after grounding from it. So that's how we get the GM after grounding.
Yeah,
So
and
can I ask a
we need
question?
hydrostatic particulars, hydrostatic table to read Km after grounding. Yeah, fine. So, very good. I think God's power, you are correct. But now we shall go to details. How to calculate displacement after grounding.
Sir, can I ask a question
Please.
about free surface correction?
Mhm.
As the vessel is in a stationary position, the fluid inside the tanks cannot move. So should we need to calculate it?
In general, yes. In general, yes. Because this is artificial shifting of the center of gravity. But usually, this phenomenon is neglected in calculation after grounding. Yeah? So we omit, we skip this problem of free surface correction because it changes vertical position of the center of gravity in millimeters or in centimeters. So to sum up, God's power saying about free surface correction was right. Yes, the free surface correction will change because displacement of our ship changes. Yeah, but at the same time, Batuhan, you are also correct. The change of free surface correction will be so small that we usually don't consider this. Yeah, but both of you are correct. From practical point of view, Batuhan is correct. From theoretical point of view, God's power is correct. But we will follow proposal by Batuhan, so we will skip free surface correction. Okay, so coming back to the issue, to the problem, calculation of the displacement after grounding. God's power proposed to do it as a first step in order to calculate initial metacentric height. Okay, so I am waiting for your proposal how to calculate DG, displacement after grounding. The silence surprises me.
Sure, as displacement is just like the sum of all weights, including the light ship, so
Mhm.
we should determine all of them.
Okay, so if we add the weight that has been discharged or the force acting on our hull to displacement of freely floating vessel, we will obtain dg. Yeah? We started with assumption. I am back to assumptions. Where was it? I don't remember where. Click, 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 click. Not here. What event? Okay. Here. What data may be used? And we started the loading condition before grounding is known. So letter D, displacement before grounding is known. So if we add to this displacement the force acting on our ship, we will obtain displacement after grounding. Is it obvious for everybody? The silence surprises me, but at the same time,
Yes, sir,
works.
it's obvious.
Yes, it should be obvious, yeah. And this is artificially discharged weight. And maybe at this stage I should stress that m as a variable is less than 0, is negative. Yeah, maybe it helps you to understand this formula. N, the variable n, the force, is negative as a number. Why is negative? Because the force acts upwards. Yeah, the force acts upwards. Displacement is positive, acts downwards. Weight is positive. Yeah, weight is positive. It acts downwards. N is discharged. N is discharged weight, so it acts upwards. It means that for the formula, for all formulas, we shall use a negative number here. And maybe I shall to come back to this formula when we calculate the force. Please answer the question. Delta Tm, is it positive or negative number? Very good question. Delta Tm, is it the number is positive or negative?
It's negative.
Negative. Tm after grounding is smaller than Tm of freely floating vessel before grounding. Yeah. For example, freely floating vessel has mean draft 10 meters. After grounding, let's say it will be 9.8 meters. Yeah. So this is a phenomenon. When the ship is grounded, mean draft is smaller. After grounding, the mean draft is smaller. Okay. So if we put numbers here and calculate change of the mean draft, the result will be negative. If the result is negative, the force will be negative at the same time. So it is important to understand and to remember. Okay, so coming back to the formula, the first is done, the first proposed by God's power, and the second one, the method how to calculate position of the center of gravity after grounding. Somebody started something about weights. So who will develop, who will invent the formula for calculations of the vertical position of the center of gravity after grounding? I'm waiting for your proposals. The sum of static moments shall be divided by the sum of weights. How many weights, how many moments? It seems to me the number shall be, who will answer?
2.
I think it should be 2, but it should be 1 in this case because the other one is 0. So if you multiply by 0, it will still be 0. So I think it should just be 1. The vertical position of, because it's on the same level with the ground, so it's 0.
Yeah.
So I think it should be 1.
Mm-hmm. Okay, so I'm not sure because I didn't switch between screens, but it seems it was God's power. God's power, was it you?
Yes, sir.
Yeah. So if I understand you correctly, the first thought was there shall be two, because the ship itself or herself, yeah. So this is statical moment of weight of the ship that floats freely, plus the artificially discharged weight, but multiplied by, and you said God's power by 0. Am I right?
Because ZP is 0 from the assumption we made in the beginning.
Yeah, very good. So it is, you did prove you follow the assumptions. For other students, I will come back to those slides. We did assume that the action point is placed on the baseline. So vertical position of this point is equal to 0. Vertical position is equal to 0. And God's power is talking about that one, yes, about 0 here. So this discharge weight, artificially of course, imaginary, the center of gravity of this weight is placed on the baseline, so vertical ordinate is equal to 0. And coming back to the formula, God's power meant this 0 here. And divided by sum of weights, so it should be d plus n. And after simplification, God's power talked about, it will be d over dg multiplied by kg. So relationship between freely floating displacement after grounding, and vertical position of the center of gravity. It will be mu artificial, of course, position of the center of gravity after grounding. And I'm back now to God's power. At the first stage, you talked us about two components, and the second stage, one component. And now I turn to you just to make sure it was your way of thinking. God's power?
Yes, sir, it is. That's what I thought about. So that's
fine. Okay, super. So very good. Done. Because the last stage, stage number 3, God's power talked about, it is just kmg, that is taken from hydrostatic table, from hydrostatic particular. You have to read the number and deduct vertical position of the center of gravity after grounding. So if you have GMG calculated, initial metacentric height after grounding, you can come back to the formula that has been used for calculation of YP. Yeah, this is the reason why we discussed initial metacentric height after grounding, just to stress that the center of gravity after grounding moves, and God's power, please finish my sentence. The center of gravity moves upwards or downwards after grounding. How do you think? Does it go down or up? So kg after grounding. What is the relationship between kg after grounding and kg before grounding? Which is bigger?
kg before grounding is bigger than kg after grounding.
Are you sure? In my opinion, kg rises after grounding. Why? Because displacement of freely floating vessel is bigger than displacement after grounding. D divided by dg for sure is bigger than 1.
Yes, sir, you're right.
And it seems to me it is described here. D, it is summation of gray and blue. dg, it is gray. Am I right? God's power. If you can name colors, yeah?
Yes, sir.
D, it is gray plus blue. DG, it is just gray. So, it is true here. Yeah, this is true. So after grounding, position of the center of gravity that ship feels goes up, rises. If the center of gravity goes up, probably initial metacentric height goes down. Yeah. So from stability point of view, grounding is dangerous. Grounding is dangerous because position of the center of gravity rises because of additional force, and at the same time initial metacentric height goes down. So it is dangerous for a ship. Actually, the most dangerous situation is if initial metacentric height after grounding is less than 0. It is dangerous. It is danger. It is really danger after grounding if initial metacentric height is less than 0. The ship loses stability. The ship has no ability to withstand in even position, in uneven keel. In upright position, it is better to say, in upright position. If initial metacentric height is negative, it is very dangerous for ship because the ship has no ability to float in upright position.
Sir, excuse me.
Please.
I have like question. Why is displacement multiplied by displacement after grounding is more than 1? Because I think that displacement after grounding is a sum of displacement, just simple, plus n. So it should be, I don't know just why.
Okay, so we are talking about this formula. Am I right?
Yes, and
Displacement plus n. Yeah.
why this ratio is bigger than 1?
Yes, but n is negative. For example, if we calculate the force n, the result of calculation will be minus 200 tons. So if
the n is negative. Okay,
yeah.
so
So yeah, it is obvious. Yeah, so dg is smaller than d, and
so
I think this drawing here also shows this idea. Displacement before grounding, this is sum of blue displacement and gray displacement.
And gray one.
Yeah. And gray, it is just displacement after grounding. Displacement after grounding is smaller than before grounding. The
Okay,
ship
so
rises.
I got it
The ship rises up, entering the ground. Entering the ground, ship goes up. Yeah, entering the ground, ship goes up. So the volume of displacement is smaller. If the volume of displacement is smaller, the displacement at the same time is also smaller. And it seems to me at this stage, that's all I wanted to present to you. If you study this problem, you will be ready to make calculations of a case. And it seems to me on Monday, when we meet for labs, I will give you a task to do. I will define a loading condition of the ship, any loading condition of the ship, and I will provide you drafts that have been read after grounding. And your task will be calculation of force acting between ground and hull, and point of action. So two ordinates, xp and yp. It seems to me this is it will be the topic of the next labs. Calculation of the force acting on our ship after grounding and calculation of the point of action of this force. Using this model. Using this model, it means following assumptions we've made during this and previous lecture. It will be taken on Monday. For your convenience, I did put a list of formulas. Okay. It seems to me that that's all. Fine. So if you need formulas, you have a set of formulas for your convenience. And the next slide is conclusion. Using the presented method, we determined, okay, it should be obvious for everybody. What have we done? What force and where, so n and two ordinates, would have to be applied in order to change mean draft, trim and least, as it was measured after grounding. I expressed this idea, the sentence, I said this sentence at least 2 or 3 times during this meeting. Using presented method, we determined what force and where would have to be applied in order to change mean draft, trim and least as it was measured after grounding. Okay, so measurement here is important. And what is the purpose of such calculations? This information, so 3 numbers, this information in terms of 3 numbers will be used for the analysis of possibilities of ships refloating. So what to do to refloat the ship on her own power, by towing or other method if may be applied. What to do to answer the question what to do to refloat the ship after grounding. If you want to answer such problem, to address such problem, first of all, you need to calculate the force and you need to calculate point of action. So it will be the next step for next lectures. Fine. 10 minutes ahead of us, so maybe I will present to you the next slide. From practical point of view, from operational point of view, this slide is very important. It's very important. I took text from regulations of Classification Society, Polish Register of Shipping. So the text is taken from regulations for rules of Polish Register of Shipping. And what is the title here? What is the title of this paragraph? Suspension of the class of ship class. Reasons for ship class suspension. And the owner notify of each case of ship grounding. So I highlight the word grounding and every damage, okay, by the ship, hull, machinery and so on, as well to agree with the date and the procedure for determination extent of damage and determination the scope and date of repair. Okay, so the ship after grounding loses class. The ship after grounding loses class. So the certificate of class is not valid after grounding. And this is the issue. This is something what I wanted to stress. Reasons for ship class suspension. The ship loses validity of class certificate after grounding. After grounding and other events, but the topic of our lecture today is grounding. So after grounding, the grounding shall be reported to Polish Register of Shipping, shall be reported to any classification society, and it should be agreed what to do further to determine the conditions to take the validity of the class back. Fine. Okay, and from my perspective, that's all. That's all. So, theory, assumptions, formulas, data for calculation, the source of data of calculation, results, and the last information was class suspension. Fine. We have 8 minutes, at least according to my clock. So maybe there are students, maybe you want to ask me a question. Maybe I can answer some questions in more detailed way. Maybe there is something to be explained once again, one more time, if you need. So now I open the floor for questions. Who would like to answer the question? To ask, sorry, to ask the question. I hear silence, so I have a question. Do you hear me? Sometimes when I hear the silence, I think there is no connection.
Yes, I hear you, sir.
Yeah, fine. So equipment like computer, tablet, internet work correctly, properly. Okay, so please think about questions at least 5-6 minutes ahead of us so we can conclude something, add something.
So can you ask a question about losing classification after grounding?
Mhm.
I remember that there are some ports, because of the tide, the vessels are running aground while loading or unloading from time to time.
Yes, that's right. And actually, in such cases, it is intention caused, for example, by tides. Am I right? You said
Yeah,
tides. Yeah. If
exactly.
there are
And
tides,
that the vessels have special classes,
yeah.
special remarks on there.
But in this regulation, grounding means grounding during the voyage. Grounding that was not it was not intended. Yeah, it is rather accident than general operation of the ship. So the grounding you are thinking about, like in port due to tides, it is something what is, let's say, normal, operational, but here suspension of class, losing the class, and responsibility of the ship owner to report the grounding to the class, it is after grounding during the voyage. Like you did hit rock or beached or anything, something like that, yeah? So this is the meaning of grounding here.
Thank you, sir.
So after grounding, probably a surveyor shall come and survey and see, determine what has happened, what damage is due to the hull. Maybe there is a need to dock, to dry dock sometimes, yeah. Maybe it is frequent. There is necessary to dock. It is necessary to dock, to dry dock the ship. Sometimes they survey the hull using remote underwater vehicles with camera, equipped with camera, just to see what happened to the hull, to the underwater part of the hull, to check whether construction is not bent, for example, like frames or plates, bottom plates, outer bottom plates. What about welding? Is there any damage to welding and so on? So frequently after grounding, it is necessary to dry dock the ship or to survey the ship using underwater camera and using remote underwater vehicle. It is frequent, at least to my experience. And after such survey, the surveyor determines the scope of repair, if necessary, of course, and date. And the ship owner has to repair the ship in the shipyard. So it is better not to ground vessels. Do you read statistics of different incidents and accidents at sea? Do you study such problems? Do you read just for your own? How many accidents during a year? What is the most frequent kind of event? It seems to me that grounding is on the first place. If we make a list of different reasons of different accidents at sea, grounding will be the most frequent on the top. Grounding will be on the top of the list. So this is the reason why you should be aware how to calculate different things, what are the methods, and maybe during the exam I will ask you to calculate initial metacentric height after grounding. It is very possible. It is possible that it will be a task during exam in June or in July. We'll see. July probably. Okay, so the formula like that, calculation of initial metacentric height after grounding, yeah, shall be used for your for the task. If you want to read KMG from the hydrostatic table, you need mean draft after grounding. So maybe I should put here TMG, yeah, and follow this formula. TFG, TAG 6 times TMG and divided by 8. Yeah. Just to read position of the metacentric point from hydrostatic table, hydrostatic particulars. To do this, you need mean draft. Okay. So, what are the questions? What are the questions? Now I think you can see me on the screen.
Yes, sir.
Yes, sir.
Hello. Fine. Okay. So let us continue this topic in practical way in terms of numbers. On Monday, I will ask you to calculate a force and point of action, and I will provide you hydrostatic table. Maybe we will use the same hydrostatic table as during last laboratories. not to create too many tables. Okay, this will be the task for Monday. How many students? 17. It is okay. And now I will close. I will stop recording. I think I did it.